Okay, recording start now.
Okay. So welcome to JavaScript testing masterclass. I initially wanted to do UI testing, but it seems that a lot of principles and a lot of things apply to generally, so apply to backend as well. A lot of the things are not only about UI, so then I renamed the presentation to a more catchy name, let's say. So just to go fast to the agenda is we're gonna talk about why testing is important, difference between different type of testing methods, difference between different testing tools in JavaScript, test matchers and extensions, how to create UI tests that are independent of implementation, and I think this is a very important part. Because some testing tools don't really offer that. How to test user interaction, how to mock, stub, and spy. We're gonna talk about what that means. We're gonna talk about end-to-end testing and what to test and what not to test, and testing best practices. So just to go through the introduction pretty fast and to why to write tests is, first of all, it helps to catch bugs earlier. So you see that the code is, you have more trust in your own code. Coding is more reliable and is definitely less headaches for developers. So no more playing whack-a-mole like the cat you've seen earlier, because that's exactly how it feels when you solve some bugs and you don't have testing in place, which can become quite frustrating sometimes. And this will offer better user experience, which definitely helps the company and helps new features to be shipped faster. So for example, I've heard that with at Shopify, they are having about a few hundred pull requests per day. So imagine doing that without automated testing. It would be crazy. So writing tests also allows developers to safely refactor code. So if you have every piece of coding tested, then you're going to be very sure that you can refactor code safely, because you know that the tests will catch the problems, the bugs that you might be introducing. And one thing that most people don't know about writing tests is that actually it can help a lot in having like self-documentation. So if you go into a new project created by a different team or other developers, and they have testing in place, you can run the tests and open up the tests, and you can just by reading the descriptions, you can know very fast on what some certain files or functions are supposed to do. And this can help a lot when onboarding new hires. Also, another important thing with testing is that it enforces code splitting and single responsibility. So you'll see that in order to be able to write tests easily, you will need to create a simpler architecture. So because for example, if you start doing testing in an existing project, creating tests is going to be a bit more harder. It can get quite complicated with spaghetti code. So because of that, if you do TDD, if you do the tests first, then this is going to force you into breaking stuff into easy to digest parts. So this will enhance the workflow, and it definitely helps in scaling the team. Now, when you find a bug, if you create a test and then solve the bug, then you make sure that that bug never happens again. So, like I was saying earlier, no more playing whack-a-mole, solving a bug, and then introducing different bugs. Now, on the business side of things, from this chart you can see how costs of fixing bugs go higher and higher at the end of the cycle. So it's definitely important to find the bugs as early as possible. And this is this is one important part that testing helps with. So now when it comes to type of tests, there are multiple classifications, but this is the pyramid of tests is probably the most popular one. And what it says is that basically the lower parts are faster and cheaper to run and to create. So it's easier to create unit tests than to create component, snapshot, integration, and end-to-end tests. They're faster to run as well, and they are more stable and offer specific errors to specific part of the file. So unit testing is basically testing one single unit, so one function, for example. So you know when the test breaks, you know exactly in which function broke. So that's why it's easier to debug, and it's also more stable compared to end-to-end tests. So end-to-end tests might introduce a lot of times introduce the server, introduce the database as well, and if you make API requests to if you make outside requests then to a different server, then this might break your tests for reasons that are not based on your implementation. So that's why end-to-end tests sometimes can be flaky, and that means sometimes it shows an error and then without changing anything, that error is gone. So they break for not for good reasons sometimes. And end-to-end tests can also be quite complicated to create because you want to go through a whole suite to the whole flow of what the user is doing. And in between, there's the integration testing, which helps you integrate different components of the app, different parts, different files, and so on. And component and snapshot testing, I put in between unit and integration test because they can actually be both. It can be either unit or it can be integration test, depending on how you create them. And manual tests, no need to talk about them. It's just doing manual stuff, which is the most expensive one, and actually is not really reliable most of the times. I mean, you cannot catch most of the bugs, but sometimes with manual testing, you can catch some bugs that you won't catch with the automated testing. Any questions so far? You can still hear me, yeah?
Yes, loud and clear.
Okay, yeah, okay. So anytime you have any questions, just stop me and ask me. Don't wait until the end of the presentation because we might not have time. So you could see here what the difference between unit testing and integration testing might be. So like you think this is safe, but if you have no integration test, then you might be quite surprised. So to get going on the testing tools for React, some of the most useful tools are Jest and Testing Library. So Jest is used both for front end and back end in JavaScript. You can do unit testing, snapshot testing, integration testing. It offers mocking, stubbing, and spice. It's used by the React team. Testing Library is also used by the React team. Offers component UI testing, and compared to other libraries, it helps to avoid implementation details in tests, and it can help you simulate user behavior as well. So there are a lot of other tools out there, but I'll just go in very briefly over them. I mean, I will not cover most of them actually. So test renderer and shallow renderer and test utilities are actually on the React documentation, but and they offer examples with them, but most of the times they actually recommend using other suite of tools. So test utilities is not really used. Shallow renderer is not recommended anymore. Test renderer is used just for snapshot testing, which is extremely easy to understand. So I'm gonna cover it later, just very, very briefly. Now, Mocha, Chai, and Sainan are usually also quite used. So Mocha is a testing framework. Chai is an assertion library, so you can do assertions with Chai, and sign-on offers spice and mocks and so on. But basically, just have the functionality of all these three together. So if you are using Jest, you don't need Mocha, Chai, and sign-on. You don't need Jasmine, and you don't need Enzyme. Istanbul is also included in Jest as well, so you don't need to use it separately. Supertest is just for end-to-end testing of APIs. So it's for backend end-to-end testing with no UI, which I'm gonna cover very, very briefly in just one slide later. Puppeteer and Selenium are browser automation tools which you can use for end-to-end testing as well, but that's not their main, that's not what they are made for. They're just made for automation. So you can scrape, you can do web scraping and other things similar to that. For UI end-to-end testing, Cypress is actually the best tool. And if we have time, if we have enough time, I'm gonna cover it later. To get going with Jest, what it offers is, first of all, the testing runner. So basically, this is like naming what the test, describing the tests and what they should do. So you can put multiple describer blocks together, imbricated, and then you'll see it on the, when you run the tests, you will basically have like a tree structure of your tests to easily find out which of your tests broke. And then in the test function, you actually do the assertion. Like you can, for a very similar, simple assertions, like we expect true to equal true, which will always be correct, obviously. And then, or you can do expect some tests. So this here, you put the data that you need, and on the right side, you use you assert with different assertion functions, like to equal, to contain, and so on. Any questions so far? Okay, no questions, I'll get. So each test file in Jest is sandboxed, so different test files run concurrently, but in one file, all the describes and test blocks within that file run in serial in declaration order, so one after the other. These are the most these are the functions that you'll use most of the times. So describe, you've seen earlier. You've seen test as well, where you start preparing and doing your assertion. A similar function that does exactly the same thing is it. In other testing libraries for other languages, you might have assert, but they're all doing the exact same thing. And you also have before all, before each, after each, and after all, which do what they say. So after each or before each test suite, in a test suite, a function will be run. So this is helpful when preparing things that you need in your tests. You can also use skip. So if you this skip only and each, you can put either on test or on describe. So when you put skip, it's going to skip that specific test or that specific describe block. When you put only, of course, it's going to run only that specific block, and that is very, very helpful when you debug your tests. So you find out which test failed, and you start debugging and stuff. You don't want to run the whole test suite in your file, so you use only to run just that test. And each is just for running a multiple tests when you want to have like a for each loop, for example. And test to do is just like having documentation on what you want to test later on and you haven't yet. Now, for the setup and third down, which are used a lot in integration and end-to-end testing, you'll use, like I showed earlier, before each and after each functions, and you can initialize a database, you can create some mocks and so on, whatever is needed in your test. And in after each, you will clear those dependency space. Okay, and so before all is similarly, they just and after all is also similar, but it just runs only once per described block. So to give an example of unit testing, testing a function. So this function is calculating a battery level. So it's gonna always return a number between 0 and 10 to for the UI to know how to render the battery, if it's full, empty, half empty, and so on. So there are 10 lines, and if the function returns 3, then I'm gonna show 3 green lines. So no need to worry about the formula itself because that's not important right now. But to check what the test is doing is, so you describe in test, you have to describe the very detailed on what the test does, because then when you run the test, a suite of maybe tens of dozens or hundreds of tests, then you want to know exactly what that test was supposed to do if it fails, right? So you go in, you read the name, you already know, even if it's a long chunk of code, then you already know what the test and the function is supposed to be doing. And here you can run, you can check. So I check here for this function, calculate battery level. I provide here the test case, everything and so on. And I expect each return of this function to equal the result I'm putting here. So basically, if I call the function calculate battery level with 796 and design building load 2000, then I expect the function to return 4. Is it clear so far?
Yeah, very. I think more detailed or deeper question, we can do it at the end.
Sure, no problem. So here I used a for each loop, which doesn't offer the best experience when logging. They expect assertions. So for a better logging, you can use test.each, like I was showing earlier. And here I provide an array of things that I want to assert upon, and then I call the function. I call the function in test.each. So this is a bit similar like a for each loop, but it creates it runs a test function for each element in this array. So it's doing exactly the same thing you were seeing earlier, but with better logging. So here you know exactly if you have a lot of cases in this test, then you know exactly which one failed. So maybe you have 10, we have dozens of them, and then you can easily find out on why the test failed. Now for matches, there are a lot of matches. I'm not gonna go through all of them because these ones, the matches themselves are quite easy to understand based on their names. So just to say some of the most used ones to be here, you use for when you check for an equal value, like I used here as well. And to equal, then you use with an object, and then you have to have return for, these are mostly for function calls with mocking, which we will see earlier. So you can assert that a certain function has thrown an error as well if you need, and so on. And if you need more assertions, actually there's, for the UI testing, there's this library called Jest, which is kind of necessary for the UI testing part. And you can test for DOM elements to be to meet certain criteria, like forms, for example, form inputs, and so on, to be empty, to be disabled, being able to have focus, and so on. And there's another library called Jest Extended, which offers even more assertions with arrays, for arrays, objects, dates, promises, and strings. So as well, I'm not going to go through all of them because they are easy to understand. There's also the expect more Jest, which offers even more matchers, but why it's useful to have custom matchers like this is because they're going to provide you with better logging later when the test fails. So for example, I can sometimes maybe you can use two different matchers that do the same thing, but the logging is very different. So I can, if I have an array, I can say expect my array dot length to be, and then I put the length that I'm expecting. But I can also do expect my array, and then I use to have length. So that's gonna offer a better logging later on. And you can also extend the expect function of Jest with your own custom matchers. So if you are checking the same functionality over and over again, it makes sense to create a custom matcher and to reuse it. There's also this library called Jest Chain, which is helpful to chain multiple assertions one after another. So you can expect one value to meet multiple conditions, multiple assertions. Now let's move to snapshot testing. So what snapshot testing is doing is when you run a test, it checks if a snapshot has been generated for that test, and if there's no snapshot for that test yet, it will just save a new file called a snapshot, and the test will pass. And if a snapshot already exists, then it's gonna check this the old snapshot with the one that it's created right now based on the test, and if they are different, the test will fail. If they are the same, the test will pass. So this can be done with a function called match snapshot, and it will save the rendered component output. So this is helpful for React, for example, to test different UI components.
Gabriel, can I check with you something? Just now I saw a test that says has even number or is odd number, something like that. Do we need to implement that ourselves, or is it provided by Jest?
Which one, here or earlier?
The one on the right hand side. So all these different tests, is it provided by the libraries, or do we have to?
So these are already created, and you can use it by extending Jest with this library called expect more Jest.
Okay.
So this libraries that I'm enumerated here, custom expect more Jest, Jest DOM, Jest extended, and this one Jest chain. All four of them are already included in the project, so you can start using them once the branch is once my branch is in master.
Okay, so you have already installed the. Okay.
Yes, and you have code completion as well. So you have all these great things already in place. Okay. 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 So what snapshot testing is doing is that instead of rendering the graphical user interface, which would require building the entire app, by using a test renderer, you quickly generate a serializable value for the React tree. So you know that React behind the scenes actually have this virtual DOM that is using which is basically like an object with different elements. So it recreates this object and checks with the old version to see if it's the same. So snapshot tests are useful when you want to make sure that UI does not change unexpectedly. In my opinion, there's so far what I know is just one situation when snapshot testing is very, very useful. Like for example, I want to refactor the API calls, let's say. So I'm gonna refactor a lot of things except the components themselves. So I'm going to leave the React components identical. I just need to refactor for performance some of the API calls and some of the stores. So in this case, since I don't want to introduce any new change in the UI, and I just refactor some other stuff, then it makes a lot of sense to do snapshot testing to make sure that my changes don't introduce bugs. Like for example, because I refactored some API calls, then maybe I'm not getting some data or I'm not passing some data to my components. But other than that, I would say that snapshot testing can sometimes be detrimental, because in my opinion, it introduces basically a tight coupling between the tests and the implementation. So imagine you change a class name, just a class name, for example, or an ID of an element, and then your test suddenly fails for no reason because you haven't changed your implementation. The test should not fail. So that's why snapshot testing should not be overused. And I know that sometimes it's abused, but even the React team says this. So this is from the React page, from the React documentation, where they say snapshot testing is an amazing tool that helps us a lot to do blah blah blah. And then at the end of the page, they say it's typically better to make some more specific assertions than to use snapshots, because this tests include implementation details, so they will break easily. So because they break easily, then it makes you to start not wanting to do tests anymore, or just update the snapshots automatically without checking if you should update them or if you actually have a bug in your code. But maybe Song Yang can share his experience as well, because I know he's been using snapshot testing before. Can you share a few words?
Yeah, sure. We were doing a refactoring because we want to migrate away from Redux, which is a global state management system to manage all the data structures for our business logic. So we want to replace it with the lightweight library called TrueStand. So our challenging part is to make sure all the business logic implemented with TrueStand should be exactly same as the one in the Redux store. So the basic idea here is we take the snapshot for every Redux store, and when we implement the same logic in TrueStand, we generate another snapshot and we compare them to see whether it's the same or not. So if it's not the same, we check whether the logic has been changed or we are doing it wrong or it's actually correct, and we can just update the snapshot. Yeah, so in this way, I don't think we have many drastic changes or blockers when we are migrating away from the old state management system. So yeah, thanks to the snapshot testing. Yeah.
Thank you for sharing. So that's basically exactly, it's a similar example to what I was referring earlier as well. So if you update the stores and you don't want to update the UI itself, you just want to make sure that it stays the same when you are updating some other things in your app, like the stores and the API calls and so on, then it's very, very helpful, because you don't need to do testing for each component individually and so on. So it's much faster in this case to just use snapshot. It's extremely easy. Okay, so for snapshot testing, that's when React Test Render is introduced. As I was telling you earlier, I will cover it just briefly, because that's at present, that's the only thing I think is very helpful, is when doing snapshot testing, you import it and you just render a snapshot, and then you check, you assert that the tree that you're rendering, that you're generating with Reactis renderer matches the snapshot. And here on the bottom, you can see how a snapshot actually looks like. So it's basically kind of the HTML and of your page and all the elements and so on. Now, two things that are important with snapshotting is that the snapshot themselves need to be committed as well alongside the code changes and reviewed. So that, they need to be code reviewed as well. So that's why they need to be, if possible, as short as possible, right? Because code reviewing them should help as well. So on subsequent tests, test runs, Jest will compare their render output with the previous snapshot, and if they match, the test will pass. So a few best practices with snapshots is that to treat them as code and code review it and commit it, like I said earlier. Ensure that the snapshots are readable by keeping them focused and short, or by using some tools that enforce some conventions. Snapshots, as I was saying earlier, they're just a complement for conventional tests. They're not a replacement and should not be overused, should not be abused, I mean. And the very important thing is that if the initial snapshot passes with bugs, because when you have no snapshot, then the first snapshot will be generated and the test will pass. So if you have a bug right there, then snapshot testing will not capture the full range of cases. So will not catch your bug. And when you have when you have a page that is interactive, then that part, the interactive part, will not be caught by snapshot testing. So you need to do other sort of testing for that. So if there are multiple sub-behaviors and it's not clear which one of is essential, wait. I'll just go through this one. And to update the snapshots, you can just run Jest-u. So basically, if you're sure that the snapshots have changed, not because you have a bug, just because you are introducing some changes, then you will update using this command. But the problem is that a single change, if a single change causes the snapshot to break, you can accidentally replace all of them. And then it will be difficult to work through and find out where the problem is. Any questions before I go into testing library? Okay, so the React testing library is used for UI testing. It has been renamed to testing library because it's not part of the React team actually. It's built by a guy from PayPal. So how to do component testing with it is, let's say on the left side, I have a component for rendering the battery that you've seen earlier. So this component receives the level of the battery, and based on the level, it needs to render the number of elements. So basically, it will show 3 battery full lines if I provide the level 3, and 7 battery empty lines, right? So to check this, basically I'm rendering the element battery. So I get the render function from testing library. I provide the prop 3. So for this case, with the screen, I can have access to all the I have access to the DOM with this kind of functions provided by React testing library, like for example, get all by test ID. So what this does is it checks the document, the whole page for elements that have test ID. So let me see if I find the. So you see here, data test ID, right? So this one is introduced especially for testing. It doesn't change the UI in any way. And instead of getting these elements by class name, which class name can be changed later And if that's changed and I'm using it, then my test will fail for no reason, because my test shouldn't depend on the class names. So that's why I'm using test ID. So when I'm adding some styles, I'm also adding this test ID as well. So I can check here that I have 3 elements with battery full, 7 elements with battery empty. And when I give battery with level 0, then I shouldn't have battery full anywhere in the document, and I should have battery empty 10 elements, so 10 lines. This is battery empty, this is battery full. And then there's another case as well. Any questions about this?
No, but I have another meeting that I forgot about in 15 minutes time. So
Yeah, no
once
worries.
I get kicked out, somebody have to do the recording, part 2.
Oh, okay. Okay.
Okay, sorry about that. Thank you.
Okay, moving on. So React Testing Library offers this kind of queries, which at first are a bit difficult to understand because the documentation doesn't specify well enough when each should be used, or it's not clear enough sometimes. So basically, this variance combined with this query, so you can have get by labeled text, get by text, get by title, and so on, and query all by text, query all by role, and so on. So when to use one, when to use another. So get by and get all by, they return either an element that they found, or they return an error if they didn't find anything. Query by and query all by, they return either the element or the elements that they found, or they return null. So this one, query is usually used for when you want to assert that an element doesn't exist in a page. So you can't really use get because you will receive an error in your test, but you shouldn't receive error like here. Where is it? So I'm using here query by test ID, and this will return null, and then I check not to be in the document. So this is how you can check for an element not to exist in the document with query. And find by and find all by returns a promise. So what's the difference between by and all by? Obviously, when you use by, like get by or query by and so on, it returns only one element. So for example, get by, if it finds 3 elements on the page, it will return an error, not the first element. And so you basically use this when you want to make sure that there is only one element in your page, and use all when you have multiple. So all this by label text and so on, I'm gonna show on the next slide how to use and which one. So you can use get by role usually for forms, for buttons, checkbox, options, radio, and so on. So this is a button. If you get by role, if you use get by role button, you can provide the name of the button as well. So maybe let's say you have multiple buttons on the page. You want to make sure that you find only the button that you're interested in, like a submit button. So then you provide here, you can provide a string or a regex. So this is I is for case insensitive. So why this is useful is, instead of getting this element by a class or by ID, which you can break the test later on, by using this, then you make sure that if you change the class or the ID and so on, that your test doesn't break for that reason. So you are not dependent on the implementation of your code. So you can use for other elements, you can use of other form elements, you can use get by role, get by label text, and get by placeholder text. So let's say you want to get an input or a text area, then you can use this text box, get by role text box. And you can, if you want to get the label, you can use get by label text actually will still return the input, not the label itself. So it will return the input that has a label with the name that you specify here. And get by placeholder text you will use only when there is no label, and you can't really put a label in your UI. This usually should not be used. Most of the times you should actually put a label element in your UI and use those. Now you can also use get by display value. So this is getting an element that is getting an input that has some value provided by the user in this case. So if you want to test when a user fills the data in an input, you can use this one. Other than that, when you're not working with forms and you're just working with divs, spans, and this kind of elements that you can't use these functions on, then you can use get by text. So imagine you have a div with child content too, and you want to find out every div that has the name child in it, has the text child in it, then you can easily use get by text. So with this, you also make sure that you don't depend on the code implementation, and your code won't broke when you change classes, IDs, and so on. For images, you can use get by alt text, or for any other elements that have alt. There's not only images, there are a few other elements as well, but most of the times you'll use this only with images. And whenever you can't use any of this, because there are cases when you still need some more flexibility, only then you should go to the next selectors. So you can use the get by test ID, which we've seen earlier. So that means you also need to use this to add this data test ID in your code. So the reason you shouldn't use this if you can use the previous ones is because this is also a little bit making your test depend a little bit on the implementation. Like if someone accidentally deletes this test ID, your test would break, but maybe that shouldn't be the case because the implementation is still the same, right? So that's why you should try to use the earlier ones if it's possible. And the last one, when no other things you can use, then you can use CSS selectors. So you get this container from the render function, and you can do query selectors like in JavaScript. So with query selector should mostly be avoided most of the times, but there are still cases when you use it. Any questions about this? Because I know that it can be a little bit hard to understand sometimes. No questions? Okay.
Hang on. Sorry. If there's a logical break, and I need to make a move, and then can somebody take over the recording? Okay. I will post this up later. So I'm going to start the recording now.
Okay.